In this video, I'm going to show you how we can prove that the sine rule is true. So, as a reminder, the sine rule is, well, either of these you could call the sine rule. The idea that sine A over A is the same as sine B over B, it's the same as sine C over C, or this other version, which is equivalent. And we want to show that this is, in fact, true, that this equality holds. So to do that, I'm going to start off with a triangle labelled with all of these letters. So we know that capital A is opposite non-capital A, capital C is opposite non-capital C, capital B is opposite non-capital B, and the capital letters make up the angles, while the little letters make up the side lengths. Now, we want to use trigonometry here. The sine rule involves sine, but all our definitions of sine come from right angle triangles. This is not currently necessarily a right angle triangle. So we need to make right angle triangles, and we do that just by adding in a perpendicular height. So now we've got a right angle here, and in fact a right angle here. Now we've got two right angle triangles. And we are going to be using both of these right angle triangles in this proof. Now I don't know what this height is at the minute. I could probably work it out, but I'm not going to. I'm just going to leave it as x. So we are going to be using these two right angle triangles to prove the sine rule. Now obviously we're going to need to involve our knowledge of sine, our knowledge of what that function is. So we know that the definition for sine of an angle is the opposite over the hypotenuse. So let's have a look at this small triangle first. No, let's have a look at this big triangle first. Big triangle first. We have got an angle here, which is capital A. So we can find sine of capital A. Well, it's the opposite over the hypotenuse. So it's going to be x over b. We can do the little triangle in much the same way. If we're trying to find sine of b, then it's going to be opposite b, the hypotenuse of this triangle. So sine of b is x over a. Now I can see that both of these expressions, both of these equations have got x involved, but there's no x in the sine rule. So I think I'm going to be trying to cancel out that x. And to do that, I am just going to times both sides of this equality by b, and both sides of this equality by a, so that we can get x on its own in both cases. So I found two equivalent statements to my two original statements where we've got x equals, x is the subject. Now if I know that x is b sine a, and I also know that x is a sine b, then because this x is the same x in both cases, it's both this height, that must mean that b sine a is the same as a sine b. Well, that's just equivalent to half the sine rule. Can you see how to get from there to there? I need to divide both sides by b and divide both sides by a. So this is just the same as that line. Now this gives us a bit of a clue of how we're going to work on. So what I can't do at the minute with this particular way of how I set up the triangle is I can't find sine b because I haven't got the opposite. Sorry, I can't find sine c because I haven't got an opposite to c. So it wouldn't make sense. And c is not part of a right angle triangle. So what I'm going to do now is I'm going to do the exact same thing again, but with this line instead. So you can see how this is still a perpendicular height. I've still made a right angle. I've still made two right angle triangles, but this time I've got c as an angle, so I can bring in sine c. So we're going to go about this in much the same way. I'm going to call this length y, just to make sure I know that it's different to the x from last time. I'm going to use the sine definition. I'm going to look at this big triangle first. We've got sine of a is opposite over hypotenuse, so that's y over c. Then look at the little triangle. Sine of c is opposite over hypotenuse, so that's y over a. If I rearrange both of those to get y equals, then I have y equals c sine a and y equals a sine c. Now, because this is the same y, those two things are equal. And if I divide both sides by a and c, I get that sine a over a is the same as sine c over c. So between those two triangles, we have brought in these two rules. We know that sine a over a is sine b over b, and we know that sine a over a is also sine c over c. Well, if all of these are equal to sine a over a, then I could just write these two statements in a more efficient way. I can just write it as the sine rule. Now, to get from this to the other version of the sine rule, we do just need to flip all the fractions, and it really is that simple. So we are done. We've proved the sine rule. Key points. To prove the sine rule for all triangles, we first need to cut up the triangle into two right-angled triangles. We can then use SAR with these new triangles to prove the statement.